so lesson 4.1's on polynomial functions. I want to talk a little bit about polynomials and what they are, and then of course what the function side of it means. So polynomials include monomials, okay? And monomials are single terms that have either a number or a variable or a number and variables, like 2x squared is a monomial, okay? When we are talking about a polynomial, we're talking about several monomials being added together. So 2x squared plus 5x minus 7 is a polynomial, okay? One of our quadratics, for example. So they like to write the polynomial function in some notation that can be a little bit confusing. What they're saying is that we have a number times x to some power, and another number times x to a power smaller, and another number times x to a power smaller than that, and so forth, until we get down to a number times x, and then finally a constant, just a number with no x's involved. Okay? So it's just a way of writing the notation to kind of explain it and define it. So when a polynomial is written in descending powers of x, we consider that to be in standard form. And the highest power that's in front is called your the number in front of the highest power is your leading coefficient. The highest power is called your degree. Okay, so let's look at a couple of examples here so you understand where I'm going with this. No variable here, right? Just has a constant. What's my highest power of x in this example? Jordan. The number is, the leading coefficient is 5. What's the highest power of x? X is to what power? 1. Good. And then 7 is a constant. Okay. How about this one? What's my highest power of x? Squared is the second power. So the highest power of x is 2. What's my leading coefficient? 2. It's the one that's in front of the highest power of x. What's my constant? 9, negative 9. Good. This one, what's my highest power of x? Cubed, so it's 3. So this is a third degree polynomial. Highest degree is 3. What's the leading coefficient? Understood. 1, right? Okay, the one that's in front of the x cubed, not written. And then what's do we have a constant in this one? No, why not? There's an x at the last one, right? Okay, so that's okay. Our constant then would be 0. So understood 0. How about this one? What's my highest power? 4. Good. So my degree is 4. What's my leading coefficient? 1. And my constant? Negative 1. So it's just a bunch of vocabulary that we'll be talking about. We want to make sure that you understand what that vocabulary is. And you've been introduced to it before, but we want to refresh your memory on it. Okay? So the whole goal here today is to do a little exploration, have a little fun. Okay? So we're going to go to Safari and open up a new tab if it's not already there. And then we're going to go to desmos.com, desmos.com. Once you're there, launch the calculator. And we've used this app before, so you shouldn't have a lot of trouble putting in these values. But we've now added some fractions that we haven't seen before. Okay? So, just a hint for you, you don't have to type f of x each time. Desmos will believe or understand that you mean f of x or y unless you tell it otherwise. Okay, so that's going to save you some time. So you don't have to type f of x equals 3/4 x plus 2. You can simply put 3/4 x plus 2, and Desmos will default to that being y equals, or f of x equals 3/4 x plus 2. Okay, that's going to save you some time. So when we do that, like I said, here's my f of x. if I want to, but you don't have to. So if I put 3x plus 5, what was it, 3/5 x plus 5? 3/4 x plus 2, thank you. 3/4 x plus 2, I need to use the divide sign. So in my keypad, I'm doing 3 divided by 4, and then you'll want to use this arrow to the right to get the x out of the denominator. You don't want to be in the denominator anymore. So arrow to the right, x plus 2. So what do we get for our first line, our first graph? What kind of function is this? Linear, okay? So what I want you to do when you're sketching this, we don't have to be really precise, but Desmos is kind enough to give us some points, right? Here's a point here between -2 and -4. If you click on that point, it'll tell you that it's -2 and 2/3, 0. So I want you to try to get a sketch that shows that you're at -2 and 2/3, or somewhere between 2 and 3, -2 and -3 on the x-axis, and then you're up here at 2 on the y-axis, and then graph your line, or sketch your line. So these will be rough sketches. They don't have to be super precise, but we want them to be fairly accurate so you can come back and decide where they're increasing, decreasing, and so forth. Yes, sir. Okay. Does everybody get that one graphed on Desmos? Okay. Now that you've got it graphed on Desmos, put it on the paper. And then, what was happening with this? We're making a quick sketch, and we want to describe its end behavior. Is it rising or is it falling on the right? Rising. This one was rising on the right, so I want you to write the word rising down there in the blank. Okay? Now you're on to the next one. You're going to type 4x minus 3. In Desmos in that same spot, or you can do it the same new graph, doesn't matter. Just don't confuse yourself by having too many. Then sketch it on your paper using those intercepts that they give you, x and y intercepts. And then tell me if it's rising or falling on the right. Okay, that one's rising as well. So write down rising. All right, so when you get to these more complex equations, okay, this one up here is the second one in the cubic section. We've got a lot going on here, don't we? Okay, the nice thing is Desmos tells us what those intercepts are, and it also tells us what the relative minimums and maximums are. So we have an intercept here at -0.768, and we have a relative minimum, small number, the lowest it becomes in this little portion of the area, at -0.299, -1.3, and so on. So, like that one again. There's another one right here at 0, -1, and so on. So try to include those in your graph if you can. Okay. So, when you're working with polynomial functions, every one of those that we worked with today were polynomial functions. Okay, nice smooth curves, no surprises there, right? So when you're just looking at a polynomial function or something that may be a polynomial function, we want to figure out A, if it is a polynomial function, B, let's write it in standard form in descending powers of x, and then C, we want to know the degree, the type, and the leading coefficient. So first let's look at these and decide if they're polynomials. What do you think about letter A? that look like something that we graphed, maybe a higher power, but something that we graphed? Yes. Okay. We have descending powers of x, nothing fancy going on here. So this one is a yes, it's a polynomial function. How about the second one? Polynomial, what do you think? Why not? What's bothering you about it? The square root. Okay, so if we took this and put this in the calculator, what would we get? A decimal. Is it okay to have a decimal and still be a polynomial function? As long as it's one of the numbers in front of the x, right? Okay. If it was a square root of 4 for the power, we'd say no. But don't let square root scare you. It's just another decimal. Okay? So this one is. But how about this one? Letter C. No, why not? Because it has a negative exponent. Okay? So with our polynomial functions, we have to only have positive exponents, and they have to be numbers. They can't be negative exponents. So this one's not a polynomial. How about this one? No again, right? Why? X is the exponent. Okay? So it has to have whole numbers for powers and no variables for powers. Everybody cool with that?
So what happens with negative exponent?
What happens with the negative exponent is then the exponent's in the denominator, and that causes it to not have that nice smooth curve.
Oh, okay.
Okay? So it won't be considered a polynomial. All of our polynomials, our degrees have to be all positive for our exponents.
What other rules are there? How do we know?
And good question. And that's pretty much it. When we stated what the names were, or what the things were, the exponents were all whole numbers. They can't be fractions. They also have to be positive. And then the coefficients are real numbers. We can't use imaginary numbers in front of our variables. So if you would see a 3i times x, not going to be a polynomial function. Okay? Whole numbers, real numbers, your degrees, your numbers up here, your powers all have to be nice numbers, not negative numbers and not variables. Okay? All right. So, is this one in standard form? Yes, because the highest power of x is 5, and then we have an x squared, and then we have no x's, right? So our highest power of x, this is a 5th degree polynomial. And it's already in descending powers of x.
So we said put in ABO, alphabetical descending. Oh.
Alphabetical descending. Exponential. Order. Okay. So the second one, is it in standard form? Nope. So what has to move? X to the 4th has to go to the front. So square root of 3, x to the 4th, plus 0.5, x squared, plus 19. Okay? What's its leading coefficient? Good. Leading coefficient is square root of 3. What's its degree? 4th. It's a 4th degree polynomial. A quartic. It's another name for it. What's its constant? Right? Okay. What was we said this was 5th degree. What's its leading coefficient? -4. And what's its constant? -2. Okay. All right, 2 more things to talk about. And behavior, you discovered this, right? What makes it rise on the right? Any polynomial. Absolutely, I'm sorry. So this is a 4th degree polynomial. The leading coefficient was the square root of 3. Yep, if we write it in alphabetical descending exponential order, your highest power is going to be your degree. And that helps set what the leading coefficient is. Okay? So 2 more things to talk about then. And behavior, what made it rise on the right? No matter what the polynomial was, what caused it to rise on the right? A positive leading coefficient. So when the leading coefficient was positive, it didn't matter what happened, we're always going to rise on the right. Doesn't matter what happens with the rest of the graph. Okay? When the leading coefficient was negative, then it's always going to fall upright. So you always know what the end result is going to be. Now, what makes the left behavior, the left side, be the same as the right side? Parabolas have the same behavior on both sides, right? Why? Because the x is squared. Okay? And the 4th power also had the same behavior on the left or right, didn't it? The cortex. So what made that happen? X to the 4th, right? Okay. Now, lines have opposite behavior on left and right, don't they? And which other one had opposite behaviors on left and right? Cubic. Okay, the cubed ones. Okay. So what do we mean then if we're going to have the same end behavior on the left and right? That's because our degree is even. Okay? And if we have opposite behaviors on the left and right, that's because our degree is odd. Okay? These are the same degree, this was even, right? But here, notice we have opposite behaviors on the left and right. That's when the degree is odd. Okay? Odd degree, opposite behaviors, even degree, same behaviors. Yes. With all of them, no matter what. Yep. No matter what happens, if they have an even power, the highest degree is even, same behavior. Whether it's rising on the right, it'll rise on the left, or if it's falling on the right, it falls on the left. But if it's an odd power, if it rises on the right, it's going to fall on the left. If it falls on the right, it rises on the left. Okay? Got about 1 minute. I think you can do everything on there on the worksheet that I gave you. Okay? So please come back with it finished. It won't take you very long.
Dragging away.